Okay, hi DiffyQs. So here are the answers to the problem set in class today. And I'm going to admit that number 3, I think I gave you one that is not solvable by what we have so far. But let's just go through these. Okay, so question number 1, here it is right here. It is an exact DiffyQ. And notice here, look how I kind of freed myself up from the M and the N. I'm just using A and B. And so when you check for exactness, right, we proceed all the way through, integrate A, then differentiate with respect to Y, okay? Making sure here, Braden, remember you asked me the question in class, we have to find f prime of y. The point here when you're using the exact differential equation method is to recognize that the left-hand side of the DiffyQ is the total differential of something, and your goal is to find what that something is. So that's what's happening here. You find f prime of y, therefore f of xy is this right here, and here we have the total differential. So this yellow part is the total differential of this, and then integrate both sides, you get right here. And these two constants you can obviously amalgamate, which means to combine. And there is your solution to the DiffyQ. Okay. Number 2, I think you all saw that this was separable. You could have also put this into standard form if you really wanted to, and then used, let's see, you could have used Bernoulli, I guess, but separable is easiest, I'd say. All right, so here we are proceeding through. I don't know that I have to really talk through the rest of this here. Okay, there's number 2. Number 3, okay, so number 3 is the one that we cannot solve. However, I will tell you this, if you went through the act of trying everything, there's no better way to study than that. So if you actually went through and studied and tried every single thing, and you found that it didn't work, that's fantastic, because none of our methods work. Absolutely none of our methods work. I tried everything. I tried exact. I tried separating. While this is separable, I got stuck with integrating this expression right here. Can you see? Right here, this guy, okay? I tried everything. So at the end of the day, this is what I've got, right? I separated, and I just said, I know I have to integrate that. That gives me the answer. I just left it as the integral because I could not figure out how this is integrable. I don't think it is integrable, actually. And then I just solved this for that. So this is one case. And Koji, you asked, can we, on tomorrow's test, can we leave any of our answers with an integral? The answer is no. All the ones that are doable on the test are ones that you can do all the way through. So once again, number 3, I apologize if that caused some frustration, but then I actually don't apologize, because if you actually went through and tried everything, that's outstanding. Okay, 4 was great. Oh my gosh, 4 was fantastic. So 4, I tried everything first. So the first thing I did here is I divided by x, right? And the problem here is that this is not in standard form. And then what did I do? And then what did I do then, everyone? What did I do here? What the heck happened from here to here? I don't know what Miss Ann was doing. How did I get an X up top? Nobody knows. Nobody knows. That's interesting. 1 minute. Let me pause everyone and then come back. I don't know what the heck I did here. Okay, sorry, I caught a mistake. I had put a negative in here somewhere, but so all this work I had to kind of like fix it. Anyway, the point I'm making here is I tried, it's not separable, okay? I tried, let's see, putting this into standard form, and I couldn't. So Bernoulli is out, and the integrating factor e to the indefinite integral of p of x is out. And then it was a matter of putting this into total differential notation. And here's my blue down here, okay? Do you see how I did that, everybody? So what I did here was I gathered well, you can see what I did here. I gathered dx, I gathered dy, and now I know the first thing that you all like to do is to check for exactness, and I don't necessarily have a problem with that. That's fine. I tend to check for homogeneous because I like to land in a separable Diffie-Q, a nice easy separable Diffie-Q. And these both functions here, m and n, are both homogeneous functions of degree 1. And because n is easier, I'm doing this sub, let y equal ux. And now here's where I had to make my negatives are all messed up. So hang on a second, let me change this here. Okay, negative xu dx, sorry, negative xu dx, and then this becomes negative x squared du. Okay, so then they're homogeneous, which means you can do that sub method. And I really like homogeneous. It's very satisfying, mostly because generally you get terms that cancel out. And you get this really lovely separable Diffie-Q. And once I'm here, let me get myself settled with you all. I'm here. And then I get 1 over x dx equals 1 over root of 1 plus u squared du. And from here, I think you can take it on through. Oh, don't even tell me that you don't know the indefinite integral of 1 over root of 1 plus u squared. I'm going to have you look that up. I'll give you a hint. It's an inverse something, an inverse of a trig function. Okay, so, and then from here you can take it all the way through. So that was what we did in class today. Griffin, were you the only one absent today? Okay, so Griffin, this took about the full period, actually. I don't think anyone finished the full period. And largely because it was my fault. Here, question number 3, because people in the class said, are all of these doable? And I gave this very kind of demonstrative, confident, yes, they're all doable. And what happened was people were grinding away like, nothing with 3 works. And as a matter of fact, again, I would, if I was trying to be egotistical, I'd say, oh, this was planned. But no, that was not planned at all. But I will say, the act of you trying all those methods, I don't know that you can get any better studying than that. All right. I hope this was clear. And I will see you all tomorrow. Like I said, competition format is very likely. And I wish you all a lovely evening. Good night.